circuits. They are communicating between them with a protocol called EB bus, energy bus. It's a standardized e-bikes protocol. It supports CAN, it supports UART, and it supports high voltages also. In this case, it's a UART communication. The motor also on board has some sort of sensory input system. It reads the sensor in the back, the Hall effect sensor. It reads the current from the motor, from the battery to the motor, and also it reads another sensor that measures, I am guessing, axial rotation on the shaft. And somehow they are combining the amperes and the rotation to calculate torque, maybe? I don't know. It's just a guess. So, this is the AB bus. Through that cable, we have the 36 volts from the battery directly with a limitation on amperes. They have some sort of control there. You can draw up to 1.5 from that interface. From the battery, you can draw directly, of course. You have the RX and TX for the UART, and the P+. The P+ is basically a switch lane. If you short the VSS and the P+, the bike comes on, and the ground. So inside the screen, when you press the on button, there is a MOSFET that closes the circuit and turns the bike on. That's how it's implemented. So how do you hack this thing? What do we mean by hacking it, right? Well, to hack it, basically you need to read from it all the data that you can read. And what is all the data? It's that communication protocol between the motor and the screen. So we don't want to mess with 36 volts. It's too much. It's not usable for us. We left that connected directly. Screen and motor, 36 volts, power, ground, and the switch are still connected directly. But what we did is we connected parallel to the UART. I don't remember my slides here. There we go. Fantastic. So, what we have there now is a Raspberry Pi with two FTDI USB adapters. One FTDI communicates with the motor, and the other one with the screen. And basically we are forwarding the traffic. We are reading from the motor, popping it on the screen, and forwarding to the actual screen. And back again. Rajesh, can we show the actual communication?
Yeah.
You know, on-off switch. You forward it also, or it shows that it's outside of the box.
We chose,
you cannot control it.
Yeah. But if you would like to do so and replace completely the screen, say, right? You can use a relay there.
Okay.
Close the circuit through the Pi, and it would have the same effect.
Okay, just one.
Yeah. Or you can use a power transistor. I just thought it would be nicer if we have a clean connection without us doing the high voltage stuff. Because 36 volts from the battery, it's easy to make an accident happen, right? If accidentally someone shorts the 36 volts to the TX or the RX, the bike will die. And that's irreparable. We cannot fix that. So that's why we chose to leave it off. Just have it there. You can open the bike from the screen, close the bike from the screen. The original functionality is there. And what we are doing is we are fishing the data with the Pi. And we can also issue new data, right? We can also write to both components independently. And well, the onboard sensors that the motor had are all reported through this protocol to the screen. And there is also extra functionality. For example, the motor is factory set to kick in after some speed. It doesn't kick in once you start to pedal immediately, but if you develop some speed, it kicks in. That is a variable that you can change through this setup. And you can make it actually kick in from point zero. If you would like to do so, I don't know. Or you could make it like at 90% load on the torque sensor kick in the motor. I really haven't looked into how they do it, but we have the same program that the company uses to program the motor that runs on Windows, and you can connect to that and change those settings. Or you can change them directly from the Pi. But then you are writing to the flash, and if you do something that is strange and weird, you will probably ruin it again.
So they both programmable? The
Yes.
screen and the motor?
No, the screen is not programmable, the screen is dummy. The motor is the central unit, if you like.
So it's kind of one ECU?
Yes. One ECU and one peripheral controller is how I see it.
Okay.
And the motor can be programmed to respond to any parameters that you set. So it could be anything from the weight to the amount of speed, to the pedals.
No, it's pre-programmed to respond to whatever they have it pre-programmed to respond. If you want to make it respond to the weight, you should add a weight sensor and do that functionality yourself. As it is now, I think it measures torque, and once the torque level is above some threshold, the motor kicks in. And also the motor has limitations. You can use it at 30% efficiency, 40%, 50%. You can change that also, that variable. But those are things that we didn't mess with, because why do so? They have programs for winter, for summer. That's how they use it. The user is not supposed to be able to tweak those things. Now, if you want to make a program that will change it on the fly with a feedback from the saddle, good luck.
What about inclination? Like if you're biking uphill,
It doesn't have anything.
it doesn't have anything.
No,
right?
but it can sense the torque. You will have more torque, I guess. So that's how it knows. It doesn't know inclination, no. It could.
Oh, thank you.
So to set up the parameter, is that a unique program? Or is it like program only one parameter for the whole software?
It's one parameter. One parameter that you can change on the fly, by the way. So, oops. Sorry.
It's more like the Pi was sitting, it's like we have disconnected the screen and the motor connection and added a Pi so that we can see the data that was going from screen to motor. So it's just, we are like a man in the middle kind of hacking kind of thing, the data between motor and the screen. So there are limited things that you can control from screen, like change light on, light off, change the gear, and there are some information. Those commands, like we had in the man in the middle kind of thing, like in the Raspberry Pi, we added one more extra interface. Instead of giving the commands from the display control, we can give it through the command also from outside.
Yeah, but basically it's what Ulrich was saying earlier, that these things are made from companies, like the motor is from Bafang.
Yeah.
And also the screen that comes with the motor is from that company. It's not made to work with other peripherals on the bike, if you like. For example, the battery, I believe the battery has extra functionality hidden. It can give you its voltage status and a lot of things, but they are not taking it directly from the battery. Instead, they are taking it from the motor.
Now, in this protocol, is there any additional parameters that should be is possible to get from motor and battery? Do we have this?
We have a decoded bias guide with what we know, because we fished it. And through a little bit trial and error, you can guess that this is the front light LED.
So it's not like the CAN protocol which has like description of something at least.
No.
Okay.
I'm pretty sure that Bafang has a full description of these things.
Yeah, I understand, but it's like the
Proprietary.
proprietary.
That's why we're hacking it, right? But I think that the battery has embedded functionality. For example, the battery has a UART connection of its own that is not used on the bike at the moment. So the battery could provide you with how much voltage it has, what's the level of the battery, what's the status and stuff. They don't use it. Same with the lock, the electronic lock over there. Sure, you can add it on the bike, but it doesn't communicate with anything else. It's a standalone application. It's a Bluetooth lock with GPS.
Well, this screen only connected by cable.
Yes.
Screen has nothing about Bluetooth.
This screen, no, the other screen, the other model has Bluetooth. And it comes with an app. But again, you can only do what you could do from those buttons over there.
Few functions, 5 to 6 functions. You can implement in it.
Can you change the gear from the command? Or is
The
it?
gear.
Yeah, because you're talking about the, right?
You can change the way the motor behaves.
Yes.
Yeah, okay, but not mechanical gear, right?
There
I
is
don't think
one
it has
gear.
mechanical
There is
gears.
no.
There is no mechanical gear.
Yeah, it's just how much the motor will kick in to support your pedaling.
Okay.
And of course, you don't want it full load all the time because then the battery would plummet. It draws 18 amperes. So that's why they have this smart way of calculating the torque and kicking in as much as you would want. So,
Sorry, just to clarify something, it's probably obvious, but I may have
Yeah.
missed it. So you can interface through the Raspberry Pi now, through command terminal, to bash terminal specifically.
Yeah.
Okay.
I mean, instead of giving from the screen, now you can give the byte data to directly to the motor, and you can get some response for that data. So each data has some meaning actually. You want what kind of data you want. Just write the data pattern, so it will return back with some data pattern on the serial.
it's pre-formatted commands, ASCII commands, with a checksum in the end. So if you want to open the LED, for example, you would issue the... Do we have it actually? Can we show
Yeah, I think
the presentation? Oh, before we show that actually, this is an example of what we did for the Lindholmen day, software day. So as you can see, the saddle is a heated saddle. And when Ulrich brought the saddle to us, he actually gave it on our hands. This is a prototype. Make it work. So we made a very crude circuit with a power transistor, a few shunt resistors, and we connected it directly to the battery and to the Pi. So the Pi, and we added a thermal, a temperature sensor. How do you call them in English? The heat resistances?
Why?
It doesn't matter. It's on the saddle actually.
Yeah.
It's taped there, so that thing measures temperature.
Oh, this is temperature sensor.
Yes. It. So this is how it works basically. You control it from the application on the Pi. You give a set point like 30 Celsius. Then it goes through the Pi. The Pi controls the power transistor with a PWM, a pulse width modulated. The heater heats, and then the sensor feeds back to the Pi the temperature. And this was a very simple application. It was no PID controlling, no nothing, just a simple if statement, if 30 Celsius, stop. And it worked really, really nice. But we have removed it now because it was easier to move without it.
Security.
Yeah, I mean, we made it on a breadboard, right? Because all cables everywhere. But yeah, let's show the actual Pi Rajas.
But can they have some gas or something,
Some?
like same as gas
No, they
to
don't.
control?
They don't actually.
So the motor is always working as